Hi guys, in this video we're going to start looking at expanding brackets, and this is a law that you learned way back in year 8 and that rule still applies. So it's called the distributive law, but when we have a value out the front of the brackets and there's an addition inside, that thing out the front, in this case our A, is going to be multiplied by that first term, and then that A is also going to be multiplied by that second term. So we end up with AB plus AC. So that rule will apply in advanced maths as well. Question number 1. Let's do that rule. I put the arrows in while I'm learning, but you don't need to put those arrows in. So it's 2 times A, which is 2A, and then 2 times 3, which is 6. Now, with the second one here, just be really careful. Out the front, there's a minus, but it's actually a minus 1. So we'd have minus 1 times 2x, which is minus 2x, and then minus 1 times minus 5. So remember that number has a sign in front of it. In this case, it's a minus. That will become plus 5. Looking at number 3. The only difference here is we've got 3 terms inside our bracket, and all that means is our term out the front is multiplied by each of those terms, and it happens to be 3. If there was 4 terms inside, we'd multiply by 4 terms. So 5a squared times 4, so 5 4s are 20, and the a squared's there. 5a squared times 3ab will give us 15, because 5 3s are 15. A cubed, because there's a squared and another a, so those powers, the 2 there and the 1 there, add to give us 3. And then we end up with, there's no b there, but we're timesing by that 1b inside there, so we'll end up with a b. Now, when we're multiplying the 5a squared by the last term, it's by minus c. So remember that that sign in front of what we have as a number or a letter takes a very important part of our answer. So 5 times, there's no actual number there, so it would be times minus 1, gives us minus 5. A squared and c, there's nothing else to multiply or add to those powers, so it's going to be a squared c. Okay, let's look at number 4. Now, in this case, for 4, popped a line in there, because that minus 2, remember the sign out the front of the number we take with it, is multiplied through. So minus 2 is multiplied by the y and then by the 3, but there's still a 5 out the front. So the 5 stays out the front here, okay? And then we add after it, or attach after it, whatever our expansion is going to be. So our expansion would be minus 2y, and minus 2 times 3 is 6. Noting it's minus 6 because that negative and that positive, when multiplied, give us a minus. The 5 stayed out there. There's our expansion. And then what we can gather is our like terms. So we have that extra step in here. Line up your equal signs to make it nice and neat. 5 minus 6 is minus 1. And our minus 2y stays there. Okay, next one. Question 5. We have 2 brackets here. Okay, we're going to look at the first one first and expand that. 2 times b is 2b. 2 times minus 5 is minus 10. Now, this negative is really commonly forgotten in our course and causes a lot of problems. There's a minus 1 there, so we're still needing to take that minus through that bracket because we can't ignore that. So minus 1 times b gives us minus b. Minus 1 times 1 is minus 1. You need to remember to gather like terms. 2b minus b is b. Minus 10 minus 1 is minus 11. Now we're going to expand the product of 2 bracketed terms like this. A plus b times x plus y. Now you may have used FOIL in the junior school. You can still use FOIL to expand it, but I would prefer that you didn't use FOIL and you understand what you're doing. So we're going to basically incorporate what we learn up above in expanding our single bracket to expanding our double bracket. So the way I like to do that is to take our first term of our first bracket, A, and write that in front of our second bracket. And then take our next term of our first bracket and write that in front of our second bracket again. So what we have is our first bracket, our A plus B, split up and multiplied, or out the front of, our second bracket. The reason I like to do it this way is a lot of the time we need to know how to get from this part here back to this part here. Okay, so we could factorize out an x plus y. So you can FOIL it, but I'd also like you to understand how this happens. Okay, and now what we do, now that we've split that up, is we just expand each bracket out. So we'll end up with ax plus ay plus bx plus by, which is the same answer as if you had FOILed that. So let's do that here as well. So there's the answer if you FOIL it. I'm going to break my first bracket up and write it as p times q minus 4 plus 3 times q minus 4. Let's line our equal signs up. I end up with pq minus 4p plus 3q minus 12. Remembering I've done the expansion with my brackets and remembered the negative sign. Let's look at the second one. Okay, so with this one, we've got a plus b squared. Now there's two ways to do this one. You can think of it as a plus b squared, a plus 5 squared. A plus 5 squared, there's two of them. That's what's happening. So you can break your bracket up. I'll do it over here again. As a times a plus 5 plus 5 times a plus 5. Or you can FOIL it. You will end up with a squared plus 5a plus 5a plus 25. Okay, so just expanding it like this, we can get like terms. A squared plus 10a plus 25. Now, that's a great way to do it. There's a much quicker way to do it. And there's a little rule there that I've tried to write a little bit neater. So if you have a square there, you can do the way I just did it, and a lot of kids do that all the way through, even through to extension. There's a shortcut, okay? And the shortcut is square the first term, so we'd have a squared, square the last term, and I've got that at the end, 25, and then we're going to have 2 times the first term times the last term. So 2 times a is 2a, 2a times 5, that's 10a. So there's my answer using the rule. There's the answer I got over here to the right by expanding my brackets. Either way works. Some of you will like to use this. It just makes it a little bit quicker, but if you're not confident, you know you're going to get it right doing it that way. Okay, the next rule that we've got to look at is called the difference of two squares. And this is probably one of the ones that you would have looked at last year in year 10, but really didn't necessarily grasp. When you have a bracket that has a term and another term that are added, and then you have another bracket multiplied by it where there are those same two terms and they're multiplied, we have a difference of two squares. So how we can write the answer to that is a squared minus b squared. Now the reason we can do that is I'm going to show the expansion. So if I did expand these brackets how I did above, so a times a minus b plus b times a minus b. What I'm going to end up with if I expand that first bracket is a squared minus ab. Expanding my second bracket, I get ab or ba, either way, minus b squared. So what happens is I had a minus b and a minus ab and a plus ab, which cancel each other out. So I end up with a squared minus b squared. Now, if you have something the difference of two squares and you don't see it, you can expand it the normal way. Okay, and you'll still end up with the same answer, but sometimes it just makes it a lot quicker to know the shorthand way. So have a look at the first example down here. I've got, in each bracket I've got 3y, in each bracket I've got 4. One I've got a plus, one I've got a minus. So what I can do is square the first term, 9y squared, square the last term, which is 16, and pop a minus in the middle. So when they're in this format, I can write them as the difference of two squares. So we can go backwards and write it the other way, but we'll have a look at that next lesson a little bit more. Okay, so if we go down and have a look at perfect squares, this is just going back over what I talked about a couple of questions up above, is the quick way to expand something. So when I have a term squared, what I basically have is a plus b times a plus b. Remember, up above we split the brackets, but I said there was a shorthand way, and I wrote it in words. It was square the first term, which is a squared, square the last term, which is b squared, and twice the first term times the second term. That's what we end up with. So that's the mathematical way of writing the sentence part that I did up above here. Square the first term, square the last term, 2 times the first term times the last term. That's what we end up with. If we had it written with a negative in the middle, so we had a minus b times a minus b, we end up with square the first term, which is a squared, square the last term is minus b. Okay, we're squaring the minus to get a positive, and we're squaring the b to get b squared, so that's still b squared, but when we go twice the first term times the second term, we get 2 times a times b, but there's a negative, so the term in here in the middle becomes minus 2ab. So if you can do the shorthand way, that's great, but if you don't feel comfortable doing it that way, you can double it, bracket it, and split the brackets and expand it or FOIL method it as well. Let's look at an example down here. So I'm going to use the quick method. So 2x minus 3 all squared, we can write it like this and then expand. Or using our shorthanded method, let's do that. Squaring our first term, which will become 4x squared, squaring our last term, which will become 9, 2 times our first term, which is 4x, times our second term, would give us minus 12x. So if you expanded this out, gathered like terms, you would end up with our final answer here as well. Let's do the next one. Very similar. You can expand it if you want to. 2x plus 3 times 2x plus 3. And expand. Or square the first term. So we'll end up with 4x squared. Square the last term and we'll end up with 9. 2 times the first term, which is 4x. 4x times 3 is 12x.